fast. And let's deploy agents on Cloud Run.
Right. It has been a very long day, a lot of a very interesting session. And thanks for staying back with me. So I think after learning how to build the AI agent and then the evaluation and so on, I think it's also good for us to understand and learn how we can deploy, manage, and observe the ADK agents on Cloud Run. So I'll be sharing some insights on some demo, how we can do it seamlessly and what are the practices. So without further ado, let's start. So for today, it's a long content, but try to make it swiftly into different topics. So getting started is a brief introduction AI agent in ADK. Then we will directly go into shortly on building AI agent in ADK. This is just to create a basic agent, weather agent, to so that we can deploy it to the Cloud Run. So our focus today will be on more on the deployment and the managing the AI agent in the cloud. So this will be the focus area, the third, the fourth and the fifth bullet points here. After we have deployed on Cloud Run, we will do some testing and whatnot. After that, when everything is up and running, we will go for the next step, something very interesting on Cloud Run. We would like to see how we can do the auto scaling with load testing. So imagine that when there are many users visiting the website or calling the services, if the Cloud Run is able to auto scale, and we would just want to run some tests on that. So after that, we will also go into a bit of a strategy how we can gradually release the new revisions. So all in all, it will be covering more towards the deployment side, and we will just wrap up with the key takeaways. Now, first, we will look into the introduction agent in ADK. I believe you may already have heard of agent development kit, the ADK. Is actually a flexible and modular framework for developing and deploying the AI agents. A lot of time we are actually looking into developing the AI agent, but what's next, right? After developing, we would like to have it run up and running on the production side. So for my session, we will be covering on the second part, the deployment. And so let's take a look into a bit of review or introduction on the ADK. So for ADK, like I mentioned, although we normally just focusing on the building the AI agent with tools or MCP and so on, but it's actually much more than that. It is a very use development friendly framework. It already cover not just building the AI agent, but also seamlessly deploy to Google Cloud. So as you can see here, we also have the evaluation and the deployments, and of course, it will can also do the artifact management, the tracing. We will also cover a bit on today. So there are a lot of components included in the ADK. So let's take a look how um, it's situated. So for ADK, it is on this side. So it's a agent specific framework. It's not. It's on building on top of can be on LangChain and so on. But because of LangChain doesn't cover much on the orchestration or deployment, it's the more related one will be the towards the LangGraph. So it is a balance of deterministic control and convenience. for building and also the orchestration. So during the agent development, I think this will be the general flow of the ADK developments. First, we define the goal and scope. What is the capability of the agent? Then we will design the agent accordingly to the task or the role. After that, we will, if it's necessary, we will build the agents and the tools or with connecting to the MCP and so on. Then after that, once it's ready, we will run and debug, and it's done. We will also cover the evaluation and the repeat again, refinement until it's ready. We will go for the deployment to the production. So this is the overview of the key capabilities of the ADK. Just to highlight, it also covered the multi-agent system design series. Can cover the more complex multi-agent system and so on. And for the highlight of the today, we want to highlight it is actually deployment ready and it's very easy to integrate and deploy. And of course, with the tracing and observability built in ADK, it's very easy for us to trace. We'll look into it in the example later, so no worries. So for the ADK, it is already available in different languages. Beside the Python, we also have the TypeScript, Go, and Java. So for our example today, we will be mainly using the Python, building AI agent using the Python language in ADK. So let's take a look. I will just go through very briefly on the building part because this will not be the highlight. So just to give, if you are not familiar with the ADK, we will go through a bit of the step for the setup, including the installation, how to create the agent project, and then set up the environment. And of course, the main part will be how can we code the agent and connect it to an external tool. Then once it's done, we will try to run with a web interface, and we will cover a bit of the traceability or observability inspection locally. So because we will be running the web interface on locally before the deploy to the cloud run. So the installation is very simple. So you just need to, for Python, you just need to pip install the Google ADK. So it's very straightforward. So next, to create the agent project, also very simple. It's much simpler than you could have imagined. So you just need to call one-liner, ADK create, this is the name of agent project. So for my demo or example today, I will create a weather agent. So once you generate this, run this command in the terminal, it will be generating the folder, the agent folder. Then inside it will just have containing the agent.py, the environment, and the init file. So of course, the next thing that we need to do is to update the agent file. So before that, let's take a look how because we are running it in the GCP, so we will need to set the environment to the connecting to our GCP cloud projects. So we'll just put it in, assign it to your project ID, and then just set as a global and use the Vertex AI Gemini model as true. Then let's take a look on the fundamental on the agent.py file. So this is the how you can easily build a simple basic AI agent using ADK. So you just need to, like in the root agent, you just declare yes agent and give it a name. So my agent name is weather agent, and I will be connecting to the Gemini 2.5 Flash model. Then here you just give it an instruction. So for this case, it will be the agent is a weather agent. So I just give a simple prompt. You are a helpful AI agent assistant designed to provide accurate and useful information on the weather. So this, it will connect to the tools I assign it, have this get weather. So of course we will need to define the get weather function or in the toolings. So we will update the tooling file. Sorry, I think this is a mistake, but I can show you in the terminal later, in the GCP later. So once it's up and run done, we will just run in web interface. You can just call the ADK web, and when it's run up, you can just test it on the locally. So very quickly, let me show you. So this is my weather agent. So I have the agent file and the tools files. So for tools, I have this get weather. The get weather is for our example here. I just create a mock weather data. So it's just like a few cities and the weather informations. And if it's not found, we'll just put saying that don't have the weather information. So let's take a look. So I have get it up and running already in my. So this is the web interface of the ADK. You can see it's very user friendly. I can see there's a one project is weather agent. So this is good. We'll start with, let's say, I think there's some issue, but I think I have it up here. So here is the example of the before the session. I have run it one time. So here I can already putting some question like your chatbot. So the agent is doing some reply here, and I just ask a question like, what is the weather in New York? So you can see that the agent is trying to detect the questions, and then after understanding it, you try to check what is the best is it relevant question, and then you can connect to the get weather. Then here you, after connecting to the tool, is getting the answer from the tool. It's be able to reply the weather in New York is sunny and so on. So just while we are here, I just would like to show you how we can do the tracing in when we're running in the local environment. So as we are, let me close this first. So whenever we are getting this conversation, you can see that there's invocation in the trace. So this will be automatically detect, and you will, for each, you will see that the invocation and how it's actually connecting to the internal. So for high, it's connecting invoke the agent, but then it's not really the ask a question on the weather. So that's why it's not calling the get weather. Then in the next question, when we are asking the what is the weather in New York, so you can see that for each of the step, you can, when I go hover into the invocation steps, you can see that it's being highlighted on my right side, right? So this part is the being highlighted. So you can, it's very easy to detect which part of the this is related to the user flow. So you can also, it's logging the execution time. So if there is a complex system, or when you would like to debug or check where is the bottleneck, which of the step is taking too long time, and if you want to further improve or optimize the timing, so you can also utilizing this tracing invocation parts to see each of the step how much time is being used. So yeah, then this is a brief introduction on tracing from the ADK running locally. So next we will go in, if we want to go into more details, right? So you can see, let's say I click on this get weather, so we'll go into the more details of this part. So it will trigger this event. So here you can see that it will giving you even more details on each of the calling. So you can see that what is the content, and so on. And here you will see that it will be connecting to different flow. So here I'm calling the sending the gateway. My question is, why is the weather in New York? It's triggering the get weather, but in here you can also see that the city it be able to capture is a New York, which is correct. So sometimes imagine that the agent is giving you the wrong answer. So let's say then in this way you'll be able to check what are the argument being passed to, what is the parameter is be able to detect, is it correct or wrong, and which part is problematic. So here, of course, this is the correct one. So if imagine that here suddenly the city, it doesn't detect as New York, maybe it become the New Jersey, then you know that the weather is actually returning the wrong result, because it's actually getting the wrong city. So you can also go into the request, how it's connecting to the model. So this is the model as we can define in the prompt. We are using the Gemini 2.5, and also you can check on the system instruction. So you will be able to detect a lot of details here. Right. And of course, the last part will be the response. You will be able to see how it is getting the answer, the result. So this is a brief overview on the first, even without being before you deploy to the server, when you are building, you can actually debug and test or trace your AI agent performance and the workflow. So this is a very, very helpful tools. Now let's go back to the slide. So this is briefly what I have been covered in the demo just now, and the traceability and inspecting the AI agent flow locally. So this is very, very helpful, because as we designing different AI agents, the multiple AI agents, we want to know how the information sending passing to the sub agent is actually validated or correct. And if anything goes wrong, it's very easy for us to debug which agent is having the problem. So, right. So this is summary of what I've shown you just now. The checking into different inspecting the different events. Now, very quickly after let's say we are have done the refinement and evaluation was not, we want to deploy to the AI agent to the production. So we will choose the Cloud Run for this case. If you are new to Cloud Run, Cloud Run is actually a fully managed serverless compute platform. So in a way, it's actually very convenient to just run your containerized application directly into the cloud infrastructure without the worrying on the scalability and so on. So we'll look into this example, how it can be done. So these are the steps for deploying to the Cloud Run. We will update the environment to connect to the for setup to the Cloud SQL for the testing and later. So for the deployment file, we actually need 3 files here. First one is the server.py. Then we have the Docker file. And the third one is a bash script so that it can run the deployment script directly. So then after the file is ready, we will just run the bash script to deploy the agent to run. So once it's done, we will be able to see the agent deploy on Cloud Run. So I think for this part, I will quickly show you the setup part, and I think it's easier if I just show you directly on the Cloud Console side. So here I am actually connecting to the Cloud SQL. So we want to update the Cloud SQL DB connection. So we just add this database connection, the name of the service. I will show you how you can get it later. And then after that, we will just create the deployment file and so on. So I think let's go through the deployment files. So this is the project, right? Outside of the project file, let's take a look on the first file. I will go to the server.py here. So what it's basically doing is to have after setting the environment and so on, so I will have the create the fast API app with the proper argument. So I have this, we will build it fast API application first. So the class feedback is getting the returning the result from the agent. Now, so this is very simple. We will just have it run the application. So once we have setting up the server file is ready, let's take a look on the second file, which is the Docker file. So for Docker, we want to containerize the application so we will have this Docker file. In the Docker file, we're just using the simple Python Docker file, and we will just install and the command will be very simple. We'll just run the server app. Right. So this is a very simple Docker file. Once this is ready, let's take a look on the deployment steps. So for the deployment batch script file, it's actually very simple as well. So first we need to load the environment. Then we will just assigning the variables on, like, especially we want to make sure the cloud project is correct and we have the database connection and name ready. Then we will just run this command. So we will call the gcloud run to deploy the project, the weather agent project applications. And yeah, this is just like in which project and which port and so on. So we will be deploying into, let's say, in US Central 1, and we are setting it be able to have a maximum of 10 concurrency. So once this is ready, we will up and running. I already have done it to save the time. So we will go into the Cloud Run service here. Here we can actually see the weather agent is already ready. We can take a look on the weather agent. So I think it's only taking like maybe 3-5 minutes to deploy. I just want to show you right. Once this is successfully deployed, you can see that they're having this URL. I can click on this part. So here, because I'm deploying into the US Central 1, you can see that we have the project and then we have the instance, and then it's connecting to the US Central 1. So let's try. So you can see it's returning a different answer, right? But I mean, it's still the similar part, but it will be may not be exact same answer every time you type, right? So let me try. I want to check the weather in Ahlen. Of course, this is hard-coded, right? I just check the weather forecast and I just say into my mock database. So it's able to get the city and returning the temperature here. So I will show you again. It's exactly the same how you trace or observe or inspect the flow or the event in when you run locally. It's actually the same how you can do it. So we can here we can check, like, it's when I getting the steps of it, you can actually go into like the different event or requests and the response to understand how it's getting there. Or if you are curious on the overall you can actually extend here. You can see like which one is calling and so on. So you can also to try understand this as well. So all in all, this is the very useful tool whenever you want to understand what is happening inside the agent. So we always say that the AI agent works like a black box, but in this way we can actually able to trace different steps or events happenings within the agent. So this is a very quick one. Now, so we have showing how we can track it locally, and then after that we also deploy it on Cloud Run. So the Cloud Run will be exactly the same behavior as you are running or testing locally. So next we'll give you a bit of the overview. Now, so this is I already show you the different part of the code, this to up the server code, and then we have the also the Docker file. This is Docker file. It's just having the simple command to run the server app. Then after that, we have the deploy to Cloud Run batch script. So it's just a simple basically it's just executing the G-Cloud run deploy with the other parameters. So to deploy it, right, I'm actually just calling the batch deploy to Cloud Run.sh file, so that it will be able to, in the terminal, is executing this script. And of course, inside the script is just called the G-Cloud run deploy, right? So once it's ready, you can go to the Cloud Run to check the agent which is being deployed on the agent side, on the Cloud Run side. So I have already shown you this one. So you can see that the URL here will be different from if you run locally. This is if you are already deployed, it has the syntax of the agent project, and then the instance, and of course the which zone you are hosting it, and then the URL full link. So here you can also see I forgot, I think later we can see. So you'll be able, once you when you click on the link, you'll be able to run your ADK AI agent application in the production. In fact, for this, I actually have set it into a public. If you are interested or curious, you can actually test this link and ask a question and so on. But with the interest of time, we will look into the auto scaling and load test. So next we will cover a bit something a bit more advanced, or more towards the production scenario. So when there are many requests coming in, so I want to test if the Cloud Run be able to auto scale and functioning as expected. So here what we will do is to simplify the flow, or we will first do a quick setup, just exporting the service URL, the new one, and we will store it in the service URL environment variable so that we don't need to type the long URL name, right? Then we will update or create and update this load test file. We will look into why it's being written in the load test, and after that we will just run the load test command to test the application. So now to export the environment is very simple. I will just export this, getting the weather agent deploy service URL and assign it to this service URL. So this is the most recent deploy URL. So then next, let's take a look on the load test here. So in the load test, what we are trying to do here is we will have this streamer user to stimulate the different traffics or call incoming requests. So here we have the wait time between 1 or 3 seconds of each task we were trying to send in new requests. So here we actually stimulate the chat streams interaction, and we have the calling to have set it to timeout for into 30. So here is actually just a simulation on sending up the request to my agent. So when this is ready, we will try to call the so this is the sending the data message. We are calling the weather agent app, and then we have the different user ID and session ID. Then text is, we are just sending it a different message now. Instead of New York, we are asking a different city, right? So we are trying to check like what is the weather in San Francisco. So when this is ready, we will try to call the client post and getting the response. So if it's be able to get a response, it will returning the reply. If not, then we'll just expect the status code. The meanings there's error and so on. Now, to run the load test is very simple. I will just call this UV run locus load test.py. So this is the command. Then I'm just setting some parameter here. So here I actually try to stimulate 0 to 60 per user request and run up to 5 user per second. So meanings for every second it could be 1 user or up to 5 users are sending requests to the agent at the same time. Then it's for the full 2 minutes period. So this is 120 seconds period. So you will be able to see after running in the crowd run there, you'll be able to see the different traffics coming in. At the beginning, there's like no traffic, and there's slowly they have some 1-2 people. Then you slowly scale up randomly and so on. So you'll be able to check the with crowd run auto scaling. It's actually when there are higher traffics coming in, it will be able to auto scale and accommodate the traffic requests. So this will be something interesting when you want to run in the production. Of course, that will be able, you can actually set how much you want to auto skew and so on. So I think the last part, I will briefly go into the gradual release to new revisions. So we have talked about the building the agent, then running the testing and deploy it. So what happens in production or in reality is the agent, like any software, we will be releasing a new version, right? So how we can do it more elegantly. So the first thing is, in this example, I will update my agent file. Let's say there's some new request. Instead of calling from the experiment from the observation, it's noticed that instead of asking the AI agent about the weather, there are people just asking some random questions, and the agent start replying, right? Because it's just connecting to the LLM. So we want to have a bit of constraint. It can only give reply on the weather questions. Anything else, you just say that it's out of the scope and so on. So once we have updated the agent file, we will run the command to redeploy the application. So here, very simple, is the same agent py file that we used earlier. What I update here is the instruction. So remember, in the earlier, we are actually saying that we have just one sentence, one in the instruction, the AI assistant to provide accurate, useful information about the weather. Then I just add another sentence. The answer inquiries about the weather, refuse or other user query. So then you just not any chatbot, right? It's just used to reply on the weather information and nothing else. So once this is being updated, let's say, okay, it's all good and so on. Let's redeploy it to the Cloud Run again. So it's very easy. I will just call this Google Cloud Run deploy into the traffic. Highlight here is this no traffic. For no traffics, it will be able, it's actually not assigning any traffic, meaning when it is done deployment, you have two revision. So we have the first revision, all the traffic is still go for the first application revision, because we are putting the no traffic here. So what we will do next is, in the Cloud Run, we will actually set the traffic in the Cloud Run. So depending on your design or need, you can slowly route your traffic to the second new revision in a more planned or careful manner. So maybe the first time I'm actually not so confident. I want to have 90% of the traffic go route to the first revision. Then only 10% of the traffic go to the second revision, the updated version, right? Then we will do some testing and evaluation. when we are more confident, we slowly increase the traffic. In this way, when we are comfortable or confident to have roll out to upgrade to the new revision, we can just assign the traffic or route to the second revision, and the first revision, the first application, it will getting the 0% traffic, and the second revision becoming the 100%. So this is very, very useful, because in the any case things goes wrong, it's very easy for us to roll back. So without much what is it called, the downtime or the hassle to rebuild or redeploy or fixing the problem and so on, we can imagine that now we are in the second revision, 80%. Suddenly things just not as expected, right? We can quickly switch the traffic percentage all back to the first revision, roll back to first revision 100%, and then the latest version back to 0 until it is fixed. So this is a very good strategy when we want to upgrade our AI agent to a new revision. So it's just not simply redeploy it, but with the Cloud Run built-in traffic allocation, you can actually design in a way to have the new revision gradually release. So I think for the last part, I will just quickly touch on the tracing part. I think, let me see if I can show you quickly on the tracing. If not, then I think maybe next time. So let me show you the right, in the Cloud Run here you can see that I only have one agent, because I think I already deleted it. If you need it, then you can actually assign it to the I'm not sure if, yeah, here you can see that there are different, whenever there's I'm sending question and so on, you will see that there's a traffic and so on. So you can also check the revision here. Here I only have one. If I deploy a second one, you can actually manage the traffic here. So here, this is the 100, send all traffics, or you want to have split the traffic across multiple revision. So this is where you can plan or manage your strategy, how you want to gradually upgrade your application. So basically this is it. Yeah, any question?
So I can stop recording and